So we've played operation on functions. Now we're going to work on composing functions, and composing not necessarily in musical scores, but composing in terms of putting two things together to make a new item. So composition of functions, it looks like fog, right? F circle G, that open circle, not multiplication. That's an open circle, that means composite. The way we do that then is we take g of x and we place it inside of f of x. We read it as f of g of x is how you will read that. The idea of composition is that you're going to substitute in g of x for wherever you see x, and you're going to then compose those two functions together. The way we do the composition is you start inside out, similar to the order of operations. You're going to follow what's in parentheses, then exponents, then multiplication, division, then addition, subtraction. So what we have here is we have f of x and we have g of x, and we're being asked to find f of g of -3. So I'm going to take -3, which was in the inside, and I'm going to put it inside of function g. Well, function g says you're supposed to do 3 times the input minus 1. So that means that g of -3 is really just -10. So now I go back over here, and instead of saying f of g of -3, I'm going to replace that g of -3 with my -10. So now I just need to find f of -10. Well, f of -10 is 2 times -10 squared, because f of x was 2 times x squared, so f of -10 will be 2 times -10 squared, which means that my final answer, -10 squared, is 100 times 2. 200 is my final answer for f of g of -3. Let's try another one. G of f of -3. So I've got -3, and I'm going to put that inside of function f. Well, f of -3 will be 2 times -3 squared. Which means that f of -3 is really just 9 times 2, which is 18. So what I really want to find is not g of f of -3, I just want to find g of 18. Well, that's not so bad. G of 18 says take 3 times 18 minus 1. 3 times 18 is 54, minus 1 is 53. So g of f, I did not leave myself enough room. G of f of -3. Come on, pen. G of f of -3 is really 53. And again, what you're doing is you're going inside out. So I took -3, and I ran it through function machine f. That gave me 18. So then I take 18 and I run it through function machine g, and that gives me my answer of 53. F of g of x. Well, this gets a little more interesting. We don't have a number we can plug in now. So f of g of x says I'm going to take g of x, which is 3x minus 1. So g of x is really just 3x minus 1. And I'm going to run that through my function f. Well, f of 3x minus 1 is 2 times 3x minus 1 squared, because again, f of x is 2 times x squared. So f of 3x minus 1 is 2 times 3x minus 1 squared. And you could leave your answer like this if you wanted to. You also could say that final answer f of g of x, you could multiply this whole guy out. So you would get 2 times 9x squared minus 6x plus 1. You could then distribute and say this is 18x squared minus 12x plus 2 would be your final answer. I want you to pause and see if you can find g of f of x. So my hint to you is figure out what f of x was, and then sub it in everywhere you see an x on g. Pause your video now and try. Okay, so I made a substitution for f of x. I replaced f of x with 2x squared. Then within the function machine g, everywhere I used to see an x, I now see a 2x squared. And then I just multiplied the 3 and the 2 together to get the 6x squared. Let's keep going. Maybe. We have a new function f and a new function g. So g of f of x, I'm going to figure out f of x was really just x to the third, which means what I'm looking for is g of x to the third. Well, g of x was the square root of 1 minus x, which means for me, g of x cubed is going to be the square root of 1 minus x cubed, because everywhere I see an x, I now replace it with, trying to get to blue, there we go, x to the third. And that's it. You can't simplify that any further. So g of f of x is the square root of 1 minus x to the third. F of g of negative 8. Well, negative 8 is just negative 8. I need to run negative 8 through function g. G of negative 8 is equal to the square root of 1 minus negative 8, which would really be the square root of 9, which is just 3. So instead of f of g of negative 8, I just want to find f of 3. And f of 3 says to take 3 and cube it, right? Because f of x was x cubed, so f of 3 is 3 cubed. And I end up with f of g of negative 8 was really just equal to 27, which is 3 cubed. Didn't miss any down there. Let's keep going. Oh boy, we're throwing an h around. H of g of x, g of h of 2. So I'm going to have you actually try those first two on your own. Go ahead and pause your video and try this first one and this second one. Don't worry about this one. We'll come back and talk together. Pause now. Pause for real. Okay, don't be freaked out by big numbers like the square root of 257. Hopefully these ones went okay with you. I took g of x and subbed it in for h, so that's the blue. There's nothing you can really clean up there because you're going to cube that square root, which is a weird thing, but that's fine. And then the second one, g of h of 2, I found h of 2 was 29. So then really I want g of 29, which comes out as the square root of 257. This last one then, I'm supposed to take g of x and sub it into f of x. So what I really want is, if f of x is x squared, that means f of g of x is f of the square root of 9x minus 4 squared. Well, if you square a square root, you really just get that f of g of x was equal to 9x minus 4. So that's good. I have f of g of x. But now I'm supposed to take f of g of x and sub it into function h. So I want h of what I just found, which was 9x minus 4. That should have been in red. So that's going to be equal to 3 times 9x minus 4 plus 5. And we are not going to cube that out. We are not going to distribute. That will be our final answer. H of f of g of x is 3 times 9x minus 4 cubed plus 5. All right, that's a lot, but this is, again, our first intro to it. So we will continue to practice in class. Don't worry at all. The last one is a story problem of how this can work in terms of composition when one thing relies on another. So the graph at the left shows a swimmer's speed as a function of time. The graph on the right shows oxygen consumption, C, that depends on speed, which is S. Time is measured in seconds, speed in meters per second, and oxygen consumption in liters per minute. So there's a lot to take in here, but basically we have speed depends on time, and oxygen consumption depends on speed. What is the speed after 20 seconds of swimming? Well, seconds would be the input, so I'm going to go to 20 seconds and find my speed. My speed at 20 seconds of swimming is 1.5 meters per second. What is the oxygen consumption when he is swimming at that speed of 1.5? So I go to a speed of 1.5 as my input, 10 looks like it's my output, and that's going to be 10 liters per minute. What is the oxygen consumption after 50 seconds of swimming? Ooh, so now I need to get somehow from time all the way to oxygen consumption. Well, the way I can do that is I can say at time 50, my speed was 2.5. So then I pick up a 2.5 speed. My oxygen consumption was 25 liters per minute. Okay, so we're using both graphs and composing together. How many seconds have elapsed if the swimmer's oxygen consumption is 15 liters per minute? Well, I'm going to look, oops, I was trying to erase. I'm going to look at 15 liters per minute, which is right here. And I'm going to say that was when we were going 2 meters per second. Well, when were we going 2 meters per second? That was at time 30. So 30 seconds has elapsed. What does the function g of f of x represent? So g of f of x, let's think about f of x first. So x was our, if we're looking at f of x was our time. So time got turned into speed. So x was time, and that got turned into a speed. Well, then g took speeds and turned it into oxygen use. So that speed got morphed through function g into oxygen use, which means that in real-world context, g of f of x is the, I keep using a Q instead of an O, oxygen based on time. So oxygen consumption based on time. You use speed as kind of the middleman to get there, because we know time will create a speed, speed will create an oxygen consumption. So thinking about it from little domain bubbles, we have time gets turned into the swimmer's speed, but then speed gets turned into oxygen. So really, g of f of x takes time and morphs it into oxygen consumption. That's it. We'll do more practice in class. It's a big topic and it's super important, so you want to make sure you understand it. Ask questions if you've got them.